Dear fellow coders, welcome to One Little Coder. There is a new image captioning model in the town, and that has been released by Sachin. Thanks to Sachin for releasing this model. And we're going to see how to use this model to create a very simple web application using Gradio, where you can simply upload an image and then that will give you the caption of that image as an output. So that's what this video is about, where you build an application where you can upload an image and you can get a caption outside. So this model that you see right now, it's called ViT to Distill GPT2 because it uses ViT and also Distill GPT2 for extracting the text, and then it has got the pretty much the code that you want to use. I'm going to use this code almost. It's not a code that I've built, but I've just made a little changes in this code just to make it slightly cleaner. And if you want to know more about how this code is created, so there is a blog post associated with the model training process, which I'll link in the YouTube description. You can check it out. And also one thing that you need to keep in mind is whenever we talk about image captioning, there is a very high chance that there are biases in the model. That's something that we need to acknowledge. That's something that we need to find ways to handle. By the time I made this video, I have done a couple of stress testing. I've used certain images, people of color, people like different images, people of like different gender images. So I try to make sure that from the examples that I saw, whether there is any bias in the text. I could not find out, but there is a possibility that you might see when you see this application deployed, you might see some biases. When you see bias, what can we do? So we are going to also discuss about that. So overall, we are going to take this code, use this model and create a web application. But first, I'm going to take you through this code line by line on a Google Colab notebook, and then we are going to convert that into a Gradio application, and then we are going to deploy that Gradio application as a web application on Hugging Face Spaces. So let's get started. First thing is keep a Google Colab notebook ready. So I've got a Google Colab notebook. It's a GPU. I'm not converting it to GPU. I'm not running a GPU environment. So with CPU environment, I'm installing transformers, Hugging Face transformers quietly. Then I'm installing Gradio. After I do all these things, now I'm importing image from Pillow, the library for image processing. From transformers, we are importing vision encoder decoder model with feature extractor and pre-trained tokenizer fast. So this is first to act as an encoder. Second, this is for feature extraction, and this is for the final text. So the first two deals with image, the last one deals with text. And for at least for the Google Colab, I wanted to take an image from a URL and then use that image for the image captioning process. So I'm using import request library for HTTP request to download an image. Okay, so let me load all this. And after we do this, now the next step is we need to now download the model, which is Sachin/ViT to Distill GPT2. So the same model that you see here, Sachin/ this is what you're doing. And let's download this model. And after we do this, now we need to download the feature extractor, whatever you would like to call it, you can call it feature extractor. And this is directly coming from the ViT base from Google. So directly Google has already uploaded this model already, and we are going to use that for feature extraction. And then once we download that for feature extraction, the next thing we need is we need to download Distill GPT2 as a tokenizer for us. So Distill GPT2 as a tokenizer. So now we have all the models, like all the required components in place. We have the model, we have the feature extractor, and we have the tokenizer in place. Now let's specify the URL from where we want to download the image. So I'm going to use this. So if you see this is the image that I'm using to see what does it show. So this is the image with which we are going to first test. It's not my image. You can see the watermarks on it. So this image, let's define the URL here. And after we define the URL, now we are going to say to open the image, get the image. So this is where we are getting the image, and we are opening the image, and that image as image, like you can see this with clause where we are calling that image and assigning it image. And that image is gone into this ViT feature extractor, and then we are extracting the pixel values of it. And after we do that, now we need to get the encoder outputs. So the model that we have, which is a vision encoder decoder model, so we are going to encode the output, and that's what we are going to do now and save it in the object encoder outputs. Now after this is done, now we are going to give this encoder outputs to this decoding, like using tokenizer. We're going to decode this and we are going to generate text. That's basically what we are doing here. So now after this, one thing that I wanted to show is sometimes you get a repeated sentence as an output here. So we want to do a very little text processing. So you can see how the output looks like. It says a woman riding a bike down a street. That's what it says. A woman riding a bike down a street, and then there is a dot, and then it repeats the sentence, sometimes completely, sometimes partially. So what I'm going to do now is I'm going to do a very naive text processing, post processing, where I'm saying split this text with dot and then take only the first element. It's a very naive text processing. So I can say this is text processing, or I can say naive text processing. Let's run this, and then you would see an output, a woman riding a bike down the street. So what do you see? Like when you see this image, would you agree? A woman riding a bike down the street. I think it makes sense. So now let's try to create this with a new image. So to quickly recap what we have done, we have installed the two libraries, transformers and Gradio. So far we have not used Gradio, and then we have imported the required components. We have imported image, we imported vision encoder model, encoder decoder model with feature extractor, pre-trained tokenizer fast, and request library to collect the image, and then we have downloaded all the models. So model, feature extractor, tokenizer, and then we have downloaded the image, given the image to the feature extractor, then we use the model to create an encoder output, and then use the encoder output to decode using the tokenizer and get the sentence. That's it. And we did a little bit of text pre-processing. Now let us quickly test whether this works fine. So I'm going to go to Google and then probably start looking for something where a lot of people walking. Okay, let's see if it I think I'm going to be tired. Okay, fine, let's finally pick this image. Okay, right click, copy. Okay, let me go to Pixabay and then right click this, open a new tab. Yes, let's copy this URL, because you need to make sure that it ends with .jpeg, otherwise you might face some problem, or JPEG or PNG, whatever, right? But you need to have that image extension. I'm going to paste this in the URL. After I paste this in the URL, I'm going to repeat all the steps. URL, feature extraction, encoder output, generate sentence, and I don't have to show you this. We can pre-process and see the output. A couple of people standing next to each other in a parking lot. So okay, it didn't necessarily talk about the car, but I think it does a decent job. Let me take one further image where I can say people in a signal, and see, maybe I think a kid with a computer should be an image. So I can go to Google, search for this image. So okay, so we have an image. I can go copy the image address. We have a JPEG here, so I can copy this, come back to this Google Colab notebook, and then I'm going to paste the URL here, run, and see what's going to show. It's still working out. So downloaded the image. Oops, sorry. Download a young boy sitting on top of a laptop. Okay, it does its job. So it's not necessarily top of the laptop, but you know, it works fine. You can test with different images. So we can finally test with this one last image, and then we will move forward to understand how it works, how to make this a web application with Gradio now. Oops, I think I copied a wrong URL. Let's say copy. Let me click this link. It should open this link from where I can download the image. Open image in new tab. Yeah, we have a JPEG URL, and then just like I said, make sure that you have the image extension at the end. Run, and then see what is it going to show. So it's processing. You can see step by step what's happening. Encoder output, generated sentence. Young boy sitting on top of a laptop computer. Once again, it says sitting on top, but you can understand that it managed to connect these images, and then it's trying to, you know, show you the output. Okay, so for now we know that we have not seen biases any, like I said, right, I tried with few images, we didn't see biases, and we know that, you know, it does its image captioning quite decent. I wouldn't say like super awesome, but quite decent. I think it should be better than a lot of existing models. I have not done any benchmarking, but yeah, you got the captions. So now our next step is to convert this script into a Gradio web application, because we want to deploy this as an application where people can upload an image and they can see the caption as an output. One of the things that you need for Gradio is you don't need to mention these expressions individually. You need to create a function, like an inference function for Gradio. Okay, so now we need to make sure how do we wrap this whatever we have created here as an inference function. So what I'm doing here is I'm creating an inference function called ViT to distill GPT2 that takes an image as an input. Okay, that's what I'm doing. That takes an image as an input, and then it does three things: extract pixel values, extract encoded outputs, extract generated text, and then return the post-processed generated text. So the last three steps that you saw here without downloading the image, everything goes inside this inference function. So let me call this inference function. Okay, so now we have an inference function defined. So the next thing is I'm going to call Gradio, import Gradio as gr. And after that, I have to specify the inputs. What do I want to show? I want to show a place where people can upload an image. So that is my input, gr.inputs.image. I've got a separate Gradio course that is on free code camp. I would recommend you to check it out. But if you do not want to know all the details, I think this should be fine. So you have got a separate input section where anybody can upload an image. You've got an output section where you have got a text box that we're going to show as the image caption. And then we have to change the title. So I took it from a different application. So the title is image captioning using ViT plus GPT2. Okay, so that is our title. So the description is, we can say ViT and GPT2 are used to generate image caption for the uploaded image. So we need to specify the model link. So I'm going to use the model link here. Go back to our collab notebook. We can say, you know, you can specify like an article here, but to keep it simple, we can just simply give the URL and then say image model repo on Hugging Face model hub. Okay, and if you want to give more details, you can give more details, but I think this should be fine for us. So we just have given a hyperlink for people to click and then go see the model, and then you can specify some example images. Right now so we need this example image in our current folder. So I'm going to download this image called bike, and then I'm going to give this bike image as an example image. So this is an example image. And then finally we are going to call the interface. So we have input, we have output, we have title, we have description, we have article, we have examples. You can have multiple examples. Right now we are using only one example, but yeah, if you want multiple examples as well, we can do that. And then we have the Gradio interface function where we are specifying ViT to distill to GPT, the inference function name, and then inputs, outputs, title is equal to title, description is equal to description, article is equal to article, examples is equal to examples, and what is the theme that you want. Because we are going to deploy this on Hugging Face Spaces, I think it makes sense to have Hugging Face Spaces theme, and then we are going to launch it first to check it here before we deploy it on Hugging Face Spaces. So let's execute this, and then see it says collab notebook detected. You've got the URL, and then you're going to get the application here. So let's see if everything is fine. It's loading. So it says image captioning using ViT plus GPT2. ViT and GPT2 are used to generate image caption for the uploaded image, and then you can upload the image here. You have an example that you can select. So I can select this example, and then I can submit this image, and then I can say, let's see what happens. 3 seconds. Right now we are not optimizing for inference. There are a lot of improvements you can do. Right now I'm just deploying it so that you can play with this. A group of people riding bikes on a city street. I think it's fine. It's a good explanation. Let me close this and then try to use a different image that I have on my local computer. Oops, it doesn't work like that. I cannot drag and drop it here. Okay, I didn't know that. So let's upload it. Let's upload it on Hugging Face Spaces, and then we can do. So right now everything looks fine. I think one thing that we didn't do is we didn't make a note about biases. So I'm going to go edit this article. Where is the article? And then say if you find any bias here, or I can add it to the description as well. Then click flag. Okay, so I want to say that. So what we want to do now is we want to tell people in the description, okay, this image captioning model, like many more models, could have, okay, I think we need to say that it used Coco dataset for training. Coco dataset was used for training. Okay, so then we can say this image captioning model might have some biases that we couldn't figure out during our stress testing. So if you find any bias, gender, race, and so on, please use flag button to flag the image with bias. Okay, I think this is quite important. Let's rerun this again to see if that text comes properly. It's loading, you can see. So it says this image captioning model might have some biases that we couldn't figure out. It's okay during our stress testing. So if you find any bias, please use the flag button to flag the image with bias. So this is the flag button, and I think we are I think yeah, it's very important for us to note it down. Okay, so right now we have everything ready. So what I'm going to do now is very simply I'm going to just comment these two. Okay, so everything else looks fine, but I don't need to download the model here. Oh sorry, I don't need any of these things. Okay, so I'm going to comment all these because I'm going to convert this into a Python script at this point. I'm going to comment all this, I'm going to comment this, I'm going to comment this as well. So I'm going to just keep this function ready where you can upload an image, and we don't need this as well. So I've commented all these things. Now I'm going to download. Go here, click downloaded this file as an app.py file. As you can see, the next thing is we have to go to Hugging Face Spaces and then upload this model. So go to Google and then say Hugging Face Spaces, and after you come here, click Hugging Face Spaces, go to your profile, make sure that you are logged in. I'm logged in my case. Create new space. After that, give the new space name. I'm going to say image captioning with ViT GPT2. Okay, what is the license? I would like to give MIT license. Streamlit, oh no, sorry, it's a Gradio application, created public, anybody can upload it. So this is the basic file structure skeleton that you have got. I can go here, upload the file, create the file. So you can go to file version. First I would like to give the requirements.txt file before I create anything. Requirements, I mean ideally this is not how you would want to create a requirements.txt file, but because we were on collab environment, I think this should be fine. First thing we need is we need PyTorch, then we need transformers, is that correct? Yeah, transformers. Then we need pillow. So PyTorch, transformers, pillow. Gradio is not required to mention here because Hugging Face by default gives you Gradio installed, so you don't have to bother about it. So create the new file, and then the next thing is go to file version, add file, upload file, drag and drop this file, the app.py file that we downloaded from collab, and then commit the changes. Just make sure one thing that by default the Hugging Face Spaces would expect your model to have the application to have app.py file. If you have a different name, make sure that you give that name here, And then again you have different emoticons, like for example, if you do not want to use this emoticon, you can go change it here. I mean, there's all the few changes that you can make to make it look better. So right now you can see it's getting built. You can go see the logs as well, like what's happening. If something goes wrong, you can read it and then see. One thing that I think we missed is that we might see a problem is we have to upload a bike.jpg image that we did not do. So I'm going to upload some image from my local machine, and then we can call that, we can upload it there. For example, let's say people walking in the street. Okay, I'm going to go upload an image from my local machine. So what is it? Such a long name, people walking in the street. Okay, upload this and then copy this image, copy the name, go to the code. While it is building, you can actually change the code so that it doesn't show any error. So in the examples we asked for bike image, but here we are giving a different image. Yes, that looks fine. Do you want to give more examples? If you want to give more examples, you need to upload more image. Let me upload an image, maybe Elon Musk. I don't know what is it going to say. I hope it doesn't say anything controversial. So upload an image, get the Elon Musk image, commit the image and save it, and then find the image name Elon Musk.jpg. You have to remember the exact extension, app.py, edit it, and then you can go and then say I have the second example, which is what am I doing? Second example, which is Elon Musk JPEG, and then save it and then commit. Yep, let's commit it and then see what's going to happen. Okay, so it's getting built now. So while it is getting built, I would like, is it done already? Oh yeah, I think it was done already, but we were making the change. So it's getting built again. So let's refresh this, and we have to wait for the example. The first one is done. I think the second one might come. Let's see if it comes. Okay, let's for now select the first one. So click this image, submit it, and then see what happens. A woman walking down a street with an umbrella. She doesn't have an umbrella, but maybe it just thought. So you can see that it is finally loaded, and you can see the images. So quickly, I made a mistake last time when you had seen. So the example should be nested list. So you need to make it a list, not like a string list. So that's something that you need to keep in mind. So we have the images ready, so we can click Elon Musk and then submit it and then see what it says. And you can say man is talking on a cell phone. Not very accurate. So let's upload another image. A man with a beard is smiling. So let me get another one and then see what happens here. This is Yannick and Siraj from their podcast. I really liked it. A man in a suit and tie holding a camera. Okay, that doesn't look very accurate. Let's try with one final image before we stop our attempts. A man with a beard is standing in front of a mirror. I think it does a decent job. So I've not tried with images with a lot of components, but I think I feel it works fine. But again, like we said, there could be biases. So just make sure that if you see any biases, highlight it. I have a feeling that we don't get to see logs here, like when we see the biases. So if you find any biases, please let the model, the author, the creator of the model know, and also you can let me know, like, so that we can see how to eliminate it in the code, the application that we build. So we can use some kind of stop words and then say, okay, like if these words are present in the output, we don't want to show an output. Like it's always completely fine to not show anything than showing something that is not correct. So yeah, that's it. I have successfully managed to build an image captioning solution using ViT to Distill GPT2, the model that has been uploaded by Sachin. Once again, thanks to Sachin for uploading this model, training and uploading this model, and you can read more about it on Sachin's blog post, which I'll link it in the YouTube description. Otherwise, I hope this tutorial was helpful to you. I hope you are going to create something like this, and let me know how it goes. So thank you so much for listening to me. Stay safe. Happy coding.